Okay, in this short video, I'm going to show how we can find the vertex of a parabola through partial factoring. This is an alternative to completing the square to find the vertex of a parabola. So what we're going to do is we're going to do this using two things that we know about parabolas from standard form. We know that they're symmetric, like every parabola, and we know that it has a y-intercept of 7. And we know it opens up in this case. So if I just do a quick sketch, it's just going to show why this works. It's not necessary. I can't factor this. I can't find the zeros. And if I use quadratic formula, it actually turns out that there are no zeros. So this is impossible to factor. This parabola has no zeros. We can still find the axis of symmetry because we know that there will always be exactly 2 points in the parabola where it has this same height equal to its y-intercept of 7. So as long as I can find those 2 points, I can find what's halfway between them, and that's going to help me find my vertex. So what I'm going to do is I'm going to find the 2 places where this function is equal to 7. So it's only equal to 7 when these first 2 terms sum to 0. So I'm just going to factor those first 2 terms. That's why we call it partial factoring. So I take out an x, and I have x multiplied by x plus 4. So this part of the function goes to 0 either when x equals 0 or x equals negative 4. You can see that on the graph. At 0, it has a height of 7, and also at negative 4, or 4 to the left, it has a height of negative 7. So my axis of symmetry must be halfway in between. I can add them up and divide by 2. So the x of my vertex must be at negative 2. So my vertex is going to be negative 2, and I just have to find the corresponding y. And I can do that by evaluating the function at negative 2. So f of negative 2 is going to be negative 2 squared plus 4 times negative 2 plus 7. You could put that all into your scientific calculator in one step. Then I get 4 take away 8 plus 7 is 3. So there's a way to find the vertex of a parabola without factoring. It works when factoring is not possible. It works when there are no zeros. It's an alternative to completing the square. What we do is we factor the first 2 terms. That helps us find the AOS, which we can plug back in to evaluate the function. And this helps us. I now know the axis of symmetry is negative 2. And I also know that this parabola has a minimum because it opens up. It has a minimum at y is equal to 3. I'll just do one more example, maybe without the sketch, just to kind of go through the mechanics of how this works. So here's another function. This one is g of x. I'm going to do the same thing. I'm going to just factor the first 2 terms. They share a minus 5x. And I'm left with x subtract 4. Positive 20 divided by negative 5 is negative 4. So this parabola, it turns out, has the same height, a height of negative 3, when x is 0 or when x is positive 4. So my vertex must occur when x is 2. So to find out that optimal value, that max or the min, I'm going to evaluate the function. I guess this function we named g, so I should say I'm going to evaluate the function g at x equals 2. So what's g of 2? Well, I'm going to replace x with 2. And then I can just plug this into my calculator. So I've got minus 20 plus 40 is 20, minus 3 equals 17. So I know now that I've got a vertex of 2, 17. And because this one's opening down, that's my maximum. That's the highest it ever gets. So it reaches a max at 17. So that's partial factoring. We're factoring only the first 2 terms. This helps us find the axis of symmetry, which I can then plug back into the function to find the corresponding optimal value. So it's just another alternative, another method, another strategy to find the vertices of parabolas. That's it. Thanks for watching, and let me know if you have any questions.